Evening, students. Today's topic is mining multidimensional association rules from relational databases and data warehouses. Okay. In our previous session, we have seen mining single dimensional association rules. We have also seen a lecture on mining multi-level association rules. Now we are going to see how to mine multi-dimensional association rules. Okay, again for this, I have referred Han and Kamber, your standard reference book for this entire course. We all know that association rule mining is finding relationships between data items, which means if a person purchases a particular item, then what is the relationship or what is the chance that he will purchase another item? Okay, by checking if these two items are related to each other or not, we are going to say whether a person will buy another item in future. Okay, we have seen in all our previous classes about market basket analysis, where where we are going to predict what a customer is going to buy in his next visit to a supermarket. Okay, so till now we have seen only single dimensional transactional data. We have seen in a particular transactional database in line item 1 what a person has purchased. Maybe a person 1 has purchased item 1, 2, 3. Okay, I think you all will remember that transactional database example that we have seen for a priori algorithm. So that is an example of transactional database. Our day-to-day activities are being recorded. But in real life, when we go to the real-time problem statements, we will have to consider not just that one transactional data, but also we need to consider many other attributes. For example, uh, in order to find how much a product has been sold in a particular uh, sales location in a particular area, we need to know the location of that particular store. We need to know how much capability that does that store have, how many peoples it can handle, how many types of products do they have in display. Coco, so um, now comes an important topic, that is multidimensional association rules, which is used for mining across multiple attributes. Here we have shown in we using age, income, location, product, and so many other factors will determine whether a person will purchase this product or not. Okay, this is considering more than one attribute. Two or more attributes is called a multidimensional association rule. The definition says multi association rules involving more than one dimension is called a multi-dimensional association rule. Okay, I have given a format for your reference. This is the format for a multi-dimensional association rule. You have one dimension, maybe this is your age. There will be a value for this. Age is between 20 and 25. There is one more dimension, which is your income. Your income might be between 40,000 and 50,000. If your age is between 30 and 35 and your income is between 40 and 45,000, then this person is going to buy, dimension 3 is buy a laptop, value is laptop. So this is an example of multidimensional association rule. So this multidimensional association rule is very much useful in relational databases and data warehouses where we have multiple attributes involved. In addition to the transaction data that we have collected, we will have a separate detail about the customer who has purchased that items, right? We'll be having a separate customer table. where we'll record the address of the customer, we'll record the age of the customer, we'll record the geographical location of the customer. And similarly, we'll be having a separate table for from where the product is procured. Okay, like what is the name of the brand from which it is procured, what are the number of items that has been brought in a particular day. All these things will be recorded in a separate table. The amount of sales that is happening every day will be recorded in a separate table. So relational databases will have all these records. We should use all these attributes in order to predict the future sales. Okay, for example, I'm saying future sales. We can predict anything that we want based on our problem statement. We will mine whatever is required. Okay, this is the basic introduction about association, multidimensional association rule mining. Next, we are going to see the key definitions in which is associated with multidimensional association rule mining. So the first one is, what is a multidimensional rule? The rule that involves more than two predicates, two or more than two predicates. Example, we'll be having age, income, and if those two are present, what will be the thing that a person buys? Okay. Next, interdimension rule. What do you think is an interdimension rule? Distinct predicates appear only once in a formula. In this formula given below, you have age, one predicate. You have occupation, the second predicate. You have buys, the third predicate. All the three predicates are different. Okay, there is no repetition in this predicates. This is called a interdimension rule. Okay, and if the predicate repeats, if the predicate repeats, then that is a hybrid dimension rule. Okay, next we are going to see two types of attributes. One is a categorical attribute and the second one is a quantitative attribute. You all know already these terms. Categorical attribute is nothing but discrete values. It will be having finite number of values. Example of that is color. Color can be either red, blue, green, and it will have an infinite number of values. Okay, occupation can be a farmer, can be a professor, can be a bank employee. Okay, this is a categorical attribute. It has a finite number of values. And quantitative attribute is numeric values. It might have continuous values. Example, age of a person is continuous, income of a person is continuous. Okay, age can also be put into categorical, but income of a person is a very good example for quantitative attribute. Okay, in this slide we are going to see three approaches for handling quantitative attributes. We have seen that there are two types of attributes. One is quantitative and the other one is categorical. In quantitative attributes, we are going to see three types, subtypes. One is static discretization. The second one is quantitative association rules. And the third one is distance-based association rules. Okay. In the first, static discretization, what we are going to do is we are going to predefine the quantitative values into concept hierarchies. Okay. I will explain this in the next slide in detail. Okay. The second type is quantitative association rule. In this, we'll be binning the quantitative attributes into, we'll be separating the quantitative attributes into different bins. I think you all remember what is binning. We'll be separating the values and putting it into different baskets or bins. But instead of doing it manually, this process is going to happen dynamically. Okay. Next one is distance-based association rule. Okay. So in distance-based association rule, we'll be using a clustering technique, and then we'll be finding the distance between the different clusters in order to write a association rule. If two clusters are close to each other, then we can map those two clusters or we can understand that those two cluster has some kind of a relation. We will be seeing in detail about these 3 points in our upcoming slides. Now, the first one is static discretization. First one is static discretization of quantitative attributes. In this, what we'll do is we'll have a raw data. We'll be having a raw data. From that raw data, we'll be drawing some concept hierarchies. Okay. From that raw data, we'll be drawing some concept hierarchies. For example, if the income is like 20,000, 21,000, 22,000, 35,000, 36,000. That is the raw data. From that raw data, what we are going to do is we are going to create concept hierarchies like 20 to 30,000 in one concept. The lower specialization is like 21,000, 22,000, 23,000. Next higher level concept is like 20,000 to 30,000. Maybe if you want to generalize further, you can add it like 10,000 to 50,000, 50,000 to 1 lakh. You understand, right? Lower level concept, middle concept, higher level concept. I'll be defining some kind of concept hierarchies. Okay. Now, what happens is our continuous income value has been discretized after drawing this concept hierarchy. Excuse for the spelling mark. Okay. So the values will get discretized, which means from continuous column, it has become a discretized columns. Now we have only 10 classes. Okay. Instead of having 100 incomes, like for 21,000, 22,000, 23,000, 23,500, all these things we have put into one bracket, 20 to 30,000. Similarly, we have done for all the incomes. Okay. So now, instead of treating the income as a quantitative value, sorry guys, instead of treating the income as a quantitative value, we'll be treating it as a categorical value. Okay. So after doing this, what we'll be doing is we'll be using a priori or other kinds of algorithm, okay, in order to find the frequent item sets. Okay. You all remember how to find a frequent item set using a priori algorithm? The same thing we are going to do for finding the frequent predicate. Okay, we are not going to find a frequent item set here because it is multi-dimensional. In item set, there is only one dimension. It will have only the value of items. But here we'll be having the age of a person, we'll be having the income of a person, and based on that, what items he has purchased. So this three, a set of age, income, and what he buys, is called a predicate set. It is called a predicate set. The first thing that we have seen in our previous classes is a item set. But here we have multiple attributes or multiple dimensions. So we call this a predicate set. In order to find the frequent predicate set, we'll be again using the a priori algorithm. Okay, I'm going to give a short summary now. We are having a raw data. We'll be generating concept hierarchies for our raw data. And then after doing this, our quantitative values have become categorical values. And then from those categorical values, we'll be able to define the multidimensional association rules. Okay, that is about static discretization of quantitative attributes. We have seen we'll be using multi-dimensional association rule mining for either relational databases or data warehouses. We all know that what the building block of a data warehouse is a data cube. So we'll be using data cubes for efficient mining of information. Okay, see, I have shown a data lattice where we have the cuboid. This is a cuboid where we have all the items at the top. We are having one item sets here. We are having two item sets here and three item sets at the base of the cuboid. Um, this is used for improving the efficiency of our association rule. Okay, of mining our association rule. I think there is no explanation required on this topic because you all know data cubes already, and we just have a point in the book that we'll be using data cubes for efficient mining. You can have a look at this diagram. This is a lattice diagram, LATTICE, lattice. Okay, we are going to the next slide. The second type of second approach to mining multidimensional association rules is quantitative association rule. What do you think is a quantitative association rule? In our last example, we have converted the quantitative values into a categorical value, and we have treated the entire thing as a categorical thing. But now what we are going to do is we are going to use the quantitative values as quantitative values itself. This is an example of quantitative association rules. In this, we have two quantitative values, one here and the other one here. And based on these two quantitative values, we'll be predicting something. Like if a person is between the age of 30 and 34 and his income is between 42 and 48K, then he is going to buy a high resolution TV. Okay, this is an example of quantitative association rules. You have two quantitative values involved, which is going to predict the two quantitative predicates involved, which will predict the which will mine the new association rule. This approach is mainly focused on optimizing the confidence of our problem. Okay, you all know what is a support and what is a confidence, right? So now what will happen is instead of statically, we have splitted the data into 20 to 20K, 30 to 30K, 40 to 40K, something like that. Okay, 20 to 30K, 30 to 40K, 40 to 50K, like that we have splitted statically in the previous technique. Here the algorithm itself dynamically allots values. It will split 30 to 30K if the frequency of that particular item is very high, or it will split 35 to 70K. See, the interval is very high because the number of items in that range might be very less. So uh, in order to optimize the confidence, in order to make sure that every quantity bracket has equal number of items occurring in it. For that purpose, we'll be using quantitative association rules. This uses grid-based clustering. Okay, this is an example of, this is a diagram where you will plot the income here, whatever income is, whatever the range of incomes we have, we'll be plotting that in x-axis, y-axis will be plotting the age in the x-axis, and then we'll be marking the place where both these things connect, or if the person is of 30 to 34K, see here it is 30 to 34K, and if his income is 42 to 48K, it is somewhere here. Then we'll be connecting that dot and we'll be writing here that that person buys a high resolution TV. Okay, let's go to the next slide. The technique that is used for this particular quantitative rule mining is ARCS technique, which means ARCS technique means it stands for Association Rule Clustering System. ARCS stands for Association Rule Clustering System. Okay, we are going to create clusters, and based on those clusters, we are going to write a association rule, which is used to organize and interpret large set of association rules. Okay, in this we are having three key concepts. One is association rule. You all know what is the association rule. It is nothing but a formula. It finds the pattern like if A and B occurs, then C will occur. Okay, we have found this in the transactional data also. Next one is clustering. You all know what is clustering, grouping of similar items together. Okay, here grouping similar rules, we'll be writing so many rules. I have said that already. For each frequent item set, we'll be writing a rule. Okay, we have seen that in a priori also. So, grouping similar rules to reduce redundancy and improve the interpretability. By seeing one rule itself, you will be able to say what is happening in that particular data. Okay, that is called interpretability. Reducing redundancy means in order to clear all the errors that is in that association rule. Okay, the third technique, the third key concept is binning. You all know that already. We have seen that in data cleaning. Okay, what we'll do is we'll be partitioning the data into equal intervals. Okay, it can be equi-width or it can be equidistance, equi-depth. So there are different kinds of binning techniques that are followed in order to do this binning. Okay, I think you all are clear with this slide. Let's move on to the next, the workflow of ARCS. So in this, we'll be doing 4 steps. The first one is equal width binning, which means we'll be separating the age into equal widths like we have done in our previous step, which means 20 to 25k, 25 to 30k, 30 to 35k, 35 to 40k. This is called equal widths. We are having equal number of interval for each numeric attribute. Okay. And after that, what we are going to do is we are going to do a 2D grid construction. What is this 2D grid construction, ma? Will be drawing a y-axis, we'll be drawing a x-axis, we'll be writing all the age related things in this x-axis, we'll be writing all income related attributes in this y-axis, and then we'll be plotting a place where both these things meet. Okay, this is the point where a person buys a high resolution TV. Okay, this is the 2D grid construction. And after doing this, I'll be going to rule generation, which is rule generation is nothing but we'll be writing rules based on this grid. Frequent predicate sets, as I have said this already, instead of frequent item set, we'll be mining frequent predicate set. A predicate set means it will be having multiple dimensions: age, income, buys. Okay, this is a predicate set. These sets are extracted based on the support and confidence. For this particular rule here, for this particular rule here, we'll calculate the support, we'll calculate the confidence. Based on this, if the support is passing that minimum support criteria, then we'll be select those things as frequent predicate set. Next one is the last step is clustering. In this, what we'll do is we'll be grouping similar rules together. Okay. For example, similar rules in this, we'll be seeing an example later in the upcoming slide. We'll go to the next slide. Okay. Rule clustering concept. Example of that is shown here. It finds the close rules, the rules that are close to each other. I said we'll be generating so many rules. Okay, we'll be checking for its support and confidence. The rules whichever satisfies the minimum, the rule that satisfies the minimum support and minimum confidence, we'll pick that separately. And from that rules, see, we'll be finding the closest rules. Age is 34. The age is 35 in the next rule. First rule, the age is 34. Next rule, age is 35. In first rule, income is 30 to 40,000. In the next rule, income is 40 to 50,000. So we can combine these two rules. Okay, these are close to each other. So I'm writing and combining these two rules and writing it as age is 34 to 35 and income is 30,000 to 50,000. Then if this is the case, then he buys the high resolution TV. The output is same for these two category of people. So we are combining this rule. This is called rule clustering concept in ARCS workflow. Okay, let's go to the next slide. The last technique is distance-based association rules. In distance-based association rules, what we'll be doing is we'll be doing clustering first. We'll be having a record like 1 lakh lines of record. For that, we'll be clustering or we'll be segmenting the customers into groups. Okay, or we'll be segmenting the age group of a person into 2 3 clusters or 4 5 clusters. Okay, this is an example of a cluster. These two people are between 20 and the price is between 20 22. These things are together. The price is 50 and 54. If you are not able to see, please excuse. 50 and 54, these things are grouped together. The things that are having closest to do distance to each other will be grouped together. Okay, this is based on the proximity. Proximity is nothing but the distance, how close it is to the next value. 20 is close to 22 in comparison with 50. Okay, so 20 and 22 are grouped together. 22 is closer to 20 in comparison with 50. So 20 and 22 are grouped together and 50 and the other value is grouped together. So it measures the closeness between numeric values or multidimensional tuples. Okay, I'll say you an example. If two customers are similar in age and spending, they likely buy similar products. Okay, if two customers are of same age, they have same income, their buying habits are same, so they are going to buy a similar product. If a person spends lavishly, he's going to buy for sure a 60-inch high definition TV. Okay, do you think he'll be his income is more? He's a lavish person, lavish spender. Okay, so he will be buying a 60-inch TV for sure. So this is a association rule. Okay, if some other person is of same age and same mentality, he is also going to buy that 60-inch TV for sure. So that is called the distance-based association rule. That is the main reason in most of your e-commerce stores, the product or videos that is recommended to you, the same videos will be recommended to your friend as well. Okay, this is because you both are at close proximity. You both are of same age, you both are from the same college, you both are from the same class, and you might have a same mentality. This is an example of distance-based association rule. Here, instead of support and confidence, we'll be using density threshold and degree of association. This degree of association is a distance-based metric. Okay, going to the next slide. The cluster-based rule mining has two phases. First is we'll be applying the clustering on the attribute tuples. On that 1 lakh line of records, we'll be applying clustering. We'll be segmenting the customers or products into different clusters. And then we'll be using diameter or density metrics. For, like I said, we'll be measuring the distance between these two things. And we'll be measuring the diameter between these two persons. And we'll be writing the metrics there, and from those things we'll be writing a association rule. That is the phase 2. So from this diagram, see, this might be bread, this might be milk, this might be bread. Okay, if a person buys milk, then he will surely buy bread. Okay, a if this is if person buys a, then he will surely buy b. And if he buys A and B, then he is going to surely buy C. Okay, this is the association rule that we have generated. This is called cluster-based rule mining. So throughout this video lecture, we have seen what is multidimensional association rule mining, what are the different approaches to multidimensional association rule mining. I I hope you all had a clear understanding of this topic. Thank you so much. Let's meet in the next class tomorrow. Thank you.